Hi ladies and gentlemen, it's Mr. Green again, and this is another in my series of lessons for pre-cal. I appreciate you all being here. Just a word, make certain you get things done because I don't want to have to close things and give you zeros on assignments that become permanent. So make certain you got everything completed before the 28th day after it's due. Okay? So we've been looking at conics. We have looked at circles. We have looked at ellipses. We have looked at hyperbolas. We have looked at parabolas, both horizontal ones and vertical ones. Now, just a word. We've got to be able to figure out how to tell these apart from each other. Now, the equations were different, and if they're given to you in standard form, it's pretty easy. It's when they give them to you in this general equation, like this one, that it becomes difficult. Okay? Now, what I want to point out to you, if we have a circle, A value here and your C value here are going to be the same. Okay? So if you've got a circle, those two values will be the same. They'll both be 1s, they'll both be 10s, they will be the same values. Even though it's a general equation, you can tell that it is a circle because this A and this C will be the same values. If you multiply A times C, and you get 0, meaning either C is 0 or A is 0. They both can't be 0 because then you would have a linear equation. If one of these two is missing, it's a parabola. Okay? And you can tell which way the parabola is pointing. If the x value is missing and you've got a y squared, that means it's a horizontal parabola. If you've got the y squared missing and you've got an x squared, it's a vertical parabola. That's the way that works, and you can be able to use that information. Okay? For an ellipse, if you multiply a times c and it's greater than 0, then you've got an ellipse. If you multiply a times c and it's less than 0, you've got a hyperbola. That's the way you can tell these apart every single time. And it's really an easy trick to just memorize these four things right here and be able to tell whether you've got a circle, a parabola, ellipse, or a hyperbola. Why do we need to know those? Because we're looking at system of equations. What's a system of equations? It's where you have more than one variable in more than one equation, and you're trying to solve them. Why? Well, what if you had two equations? Draw a little x and y axis here, Mr. Green, so that we can see this. What if I had an equation with a line, a linear line? We can draw that one really easily, like this, and a parabola. Well, a parabola would do this, right? How many times does that line hit that parabola? Well, it could hit it 2 times, like we see it right here. It might hit it at a tangent place and only hit it once, or it might touch it none at all, right? So it's either 0, 1, 2, or 3. 0, 1, 2, 0, 1, or 2, right? Those are the types of things that you're going to be looking at with a system of equations. Is if I have a parabola and a line, how many times are they going to hit each other? Okay? Well, what if it's not a parabola and a line? What if it was a circle or an ellipse? How many times will those touch? 0, 1, or 2. That's easy. So that one's not that much different than it was with a parabola, right? What if it's a hyperbola? Well, what's a hyperbola? Well, a hyperbola does this and like this. Okay? They're opposite each other. And how many times do these touch? Well, they could touch not at all. It could be one of the asymptotic lines in there. They could cross just one of them like this one does, and you get 2 times, right? But if it happened to hit in a way that it hit both hyperbola, it could be 3 times even, or it might be 4 times. Can you see that? Right there, I've got it hitting that hyperbola 4 different times. Right there, I've got it touching it 3 times. Right there, it's only hitting it 2. Can you see that? Okay, try it this way. There's 2. There's 3. and then there's 4. Ooh, interesting. What happens if it's a circle or ellipse in a hyperbola? Yeah, they could not touch at all. They could be such a way that they don't touch in any way, shape, or form, right? Those don't touch. 0. It could touch once. It could touch twice. It could touch 4 times. Could touch 3, sure. 4. Could touch more than 4. I don't see how it could touch more than 4. Okay, we're back to 3. We're back to 2. And we're back to none. 1 or 1 and none. So, you're kind of getting the feel for what we're going to be looking at with a system of equations. How do you solve a system of equations? Well, if they're linear lines, you knew that there were 3 different methods, right? You could either substitute one into the other, solve it for a value, one of the variables, and substitute it into the other one. You can do that same thing here. You solve one of the equations for a value and substitute it into the other equation, and that can give you a solution. Okay? You might be able to substitute a binomial. Remember, we've got those x minus h and x minus h. What if those were the same x minus h's in both situations? You might be able to replace a binomial in one equation with another equation. That's possible. Always sketch it out to see what the possible intersections might be so that you know how many there would be. Oh, one other trick. In case you didn't notice it, the hyperbola and the ellipse both are equal to 1. There was a transitive property of mathematics that we have that says if they're both equal to 1, then they're equal to each other. Set them equal to each other. Solve them from that. Okay? That's one way of solving a system of equations. Cool? Okay. I've talked you through the system of equations. If you have any questions, feel free to give me a call. Come by the toga. Let's talk about it. I want to make certain you understand these things. I'll look forward to seeing you.